Okay, welcome to Get Ready for Calculus. We're going to look at Skill 1, the entire page. We've already taken a look at the first problem, the remember how. Let's go straight down the left column. We are converting radicals into rational exponent expressions, and we're going to put everything in the numerator, even if it's negative. So, for instance, this first one we can rewrite 1 over parentheses 7x to the 1/2 power, but we do want to put it up in the numerator. That really helps us with a calculus process that we will learn a couple of months into calculus class. So 7x in parentheses to the negative 1/2 power. Now granted, that is not proper for algebra, but it is necessary for something we'll do in calculus. Next, it's already in the numerator. That entire expression is to the 1/2 power. We can write it just like that. I think that what you'll most likely see that power written on the cosine, and that also means the same thing. Now, it's not, and I'm going to change colors here, it is not going to be cosine to the 1/2 of x. The 1/2 and x squared do not cancel out because it's the square root of cosine x squared, not just of x squared. X squared is part of the cosine operation. So you have to keep it part of it. All right, the next one, we are going to say, okay, we have x minus 5 raised to the second power. Cubed, though, will be a fraction like that. So x minus 5 parentheses to the 2/3 power. And the last one in this group, it looks like a lot going on. Let's work on that denominator first, all of this to the 4th power, so that x is raised to the 3/5 power. And then now we can take that 1 to the 4th power and that x to the 3/5 to the 4th power. Power to power we multiply, so that's 12/5. And of course that is 1 over x to the 12/5. However, we said for our purpose we want everything in the numerator, so that 1 times x to the negative 12/5. So x to the negative 12/5 is the correct way to write that one. Okay, now the right side of the column will be converting these rational exponent expressions back to radical expressions. So after we've done our calculus process, we've taken the derivative or we've integrated, then sometimes we'll need to write the answer back as a radical, especially if we're trying to match it up to a multiple choice answer. So convert sine to the negative 1/2 of x minus 3 to a radical expression. So this, we're going to go ahead and realize that I can move it to the bottom and make it positive 1/2 for the exponent. And then we know that that 1/2 means the square root of the whole sine expression. And that is the correct answer for the first one. Second one, x to the negative 1/2. Again, move it to the bottom to make it positive 1/2 power. And that becomes 1 over the square root of x. The next one, it's already on the bottom, 1 over x to the 1/2 power, so that's 1 over square root of x as well. And then finally, 4 times x to the 3/4. Notice that the 4 is not part of the power, so the 4 will stay there. And then that x is getting a 4th root raised to the 3rd power. And so that's the way to do that. Or you might see it like this, 4th root of x, all parentheses to the 3rd power. That all means the same thing. All right, well, let's finish with an AI-generated math joke of the day. Let's see. Tell me a math joke about powers. Let's see if it can figure out anything about that. So here we go. Why was the math book so confident about its knowledge of powers? Because it knew its exponents to impress. It knew its exponents. I'm trying to say that in a different way that'll make it sound funny. And wow, that's just not quite getting it. Hey, maybe you get that joke. If so, share a comment in the YouTube comments. Otherwise, have a great day. That is skill 1, the entire thing. Keep working on these skills. Go to Pythagorean.com for if you want a PDF of this or to share it with somebody else. Thank you. Bye.